All right, Advent of Code, day 5. Here we go. Binary boarding. You board your plane only to discover a new problem. You dropped your boarding pass. Write a quick program, scan all the boarding passes, find your seat through process of elimination. Instead of zones or groups, airline uses binary search partitioning. Seat might be specified like front, back. Okay. Where's my input? Okay, got my input. That didn't work super well. First time characters will be F or B. Specify exactly one of the 128 rows on the plane. First letter indicates whether the seat is in the front. Okay. Got it. Last 3 characters will either be left or right. Every seat also has a unique seat ID. Multiply the row by 8 and then add the column. So in this example, the seat has ID. Okay. Stirs. Def seat ID row. Seat stir row equals stir 7. Seat equals stir 700. Puts row puts seat ID stir 0. Okay, inclusive. All right. Rows equals 64, 32, 16, 8, 4, 2, 1. Row num equals stir.zip rows.each do .cars ch n if ch equals f n else 0 seat num equals seat 4 to 1 equals row seats, and if it's if it's in the front half, we don't take it, and if it's in the right half, we take it. Row num times seat num. Stirs.map s seat ID s.max puts 35. Map dot sum map dot sum 889. Dang. What did I do wrong? Puts row, puts seat. $64, 32, 16, 8, 4, 2, 1, 4, 2, 1. Ah! 714. What? Oh God, I didn't read everything. Then add the column. 826. Gosh darn it. That's so poor. One, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3. Oh, terrible. What is the ID of your seat? Each do deltas equals deltas dot each do puts k if v equals 2. Oh. What? Your seat wasn't at the very front or the back, though. Some of the seats at the very front and the back of the plane don't exist on this aircraft. Puts I don't understand this. The seats with IDs +1 and -1 from yours will be in the list. If deltas dot key I don't understand. Oh, your seat should be the only missing boarding pass in the list. Oh, okay. Row num row if row num row not equal 127 if row not equal 0. What? Puts seat IDs puts seat IDs dot inspect dot sort. Min equals seat IDs dot min. All seat IDs equals set dot new. For n in puts n if all seat IDs. Oh, that was terrible. That was so bad. I did not understand that question. Ugh. How did I do on my leaderboards? Dang it. Wow. Did not do well on that one. Okay. All right. Let's clean up this input just a little bit to actually print out both parts. I don't need that. I don't need any of that. Stirs.map. Puts part 1 IDs.max. Part 2. Oh, I don't need that. All right, that was a disappointment. Did not do very well on that one. I bet the leaderboard was quite fast. Wow. This is just insane. Okay. Yeah, so explanation. Oh, I never stopped my second timer. Whatever. Explanation of what went on here. So I'll kind of read through the story at the same time. Binary boarding. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. You write a quick program to use your phone's camera to scan all of the nearby boarding passes. Your puzzle's input. Perhaps you can find your seat through process of elimination. Instead of zones or groups, this airline uses binary space partitioning to seat people. A seat might be specified like FB, FBB, FFR, LR, where F means front, B means back, L means left, and R means right. Yeah, so we're just boarding the plane. 7 characters specifies one of the first 128 rows. Each letter tells you which half of the region. What's up, Mighty Master 99? Did you participate in Advent of Code just now? Each letter tells you which half of the region the given seat is in. Start with the whole list of rows. First letter indicates whether it's in the front or back. And then after that, you have L or R, and these specify exactly one of the 8 columns. And L means lower half and R means upper half. So what this ends up being is we have 1, 2, 3, 4, 7, 8, 9, 10. We have, to get the seat ID, we multiply the row, which is this, by 8, and then add the column. So it just ends up being every number in here is just a binary number between 0 and 1024, and this where a 1-bit is a B or an R, and a 0-bit is an L or an F. That's all it is. And so we need to find the highest value, which, so I already wrote that, but I bet if we sort this, front is low, right? Yeah, so we want the B are the bigger values, and then L and R is the higher value. So we want what starts with BB. These are the things that all start with BB, FF, BBB, and then this has the highest bit R. Am I dropping frames? I'm not dropping frames, but my camera is sometimes laggy, and I don't really know why that is. But I will quit some other programs. So we get this value, which is, what is this? 2 plus 4, 8, plus 16, plus 32, plus no 64, 128, plus 256, plus 512 will get me my part 1 value. So I can just, I got it just by sorting these. And then my seat is just the missing value in this list. Cool. Yeah, so that's stuff that I realized afterwards going over this again. But how I actually solved it is I get the strings, I have a rows and seats array, which are just the powers of 2. And then I split the string into the row part, which is the B and the F's, and then the seat part, which is the L and the R's. I never know whether this is inclusive or exclusive, so I just put a big number here. And then I zip the row numbers with the row characters with these values. And then if the value is back of the row, then I add this digit, otherwise 0, and then I sum them up. And then the same thing for the seat numbers, but with this other array, and then return row num times 8 plus seat num. And so the part 1 is just the max of those seat IDs. And then for the second part, I get all the seat IDs, and then I really did not understand this. Your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist. So they'll be missing from your list as well. And it wasn't at the very front or the back. The seats with IDs plus and minus 1 are on your list. So it's like, what it ends up being is you have a long list of numbers, or the IDs that you're given are a long list of numbers. And when you sort them, you have every value from the minimum to the maximum except 1, and that missing 1 is your answer. But at first I thought I was like reading this part, and so I thought they were going to be like sparse, and that like there were going to be 2 IDs that sandwiched yours, and then that was going to be your seat rather than your being like the only missing one. Yeah. But, oh well, tough. That's it. Any more of the story here? Completely full flight. Cool. Alrighty. I'll save that. And 5th 2020 solution. Cool. And that's admin and code day 5.